We will continue with the concept of sets, but we will focus in today's lesson on 4 objectives. Objective number 1, identifying the term universal set. Objective 2, listing the subset of a given universal set. Objective 3, identifying equal sets. And objective 4, using the symbol subset and belong correctly. Example 1, we are given a set U that has 3 elements, 1, 2, 3. Now U here is called a universal set. What do we mean by a universal set? A universal set is a set that contains other sets. Now, usually in any assessment or in any exercise, the universal set is given and it is symbolized by the letter U. The question is, list all the subsets of U. What do we mean by subsets? This means how many other sets can you make from the universal set U? Let's see. I can make a set A that has no elements. It is empty. It has no elements inside it. And we call this set an empty set. And it is given the symbol phi. This is the symbol of an empty set. Can we make other sets? We can make also another set, let's call it B, that is made up of one element, for example 1. Or another set C that is made also from one element, which is 2. Or D that is made up also from one element, that is 3. Do we have other options? Yes, we can make a set E that is made up of 2 elements. They are 1 and 2. Or set F that is also made up of 2 elements, and they are 1 and 3. We can also make another set, which is G, that has also 2 elements, 2 and 3. As well, we don't have any other options except for the universal set, which is made up of 3 elements, 1, 2, and 3. All of those sets, whether they are A, B, C, D, E, F, G, they are subsets of the universal set U. We call them subsets. This means they are smaller sets made from the universal set U, which is given. Some might come and tell me, but there are more subsets than the one you wrote. Why don't you write 2, 1? But look carefully. A set that has the elements 2, 1 is the same as a set E that has the elements 1, 2. So this is the same subset. Or we can write 1, 3 or 3, 1. Same thing. Or 3, 2. So they are not counted or considered as different subsets. They are the same because in sets the order is not important. Example 2. You have the universal set U, yellow, red, blue. So here we have the universal set. As I told you, universal set is usually given. It has 3 elements and they are yellow, red, and blue. The question is, list all the subsets of the universal set U. Remember, subsets, they are the sets that come from the universal set. Let's start listing them. We will start first of all with a set that has no elements. We're gonna name it A. It has no elements, or we can give it the symbol phi. This is an empty set. We will go to another set that has 1 element, for example, yellow. Then another set that has 1 element, red. We move step by step. No elements, then all the possibilities of the sets that have 1 element only. Then D, 1 element, blue. I can't form more sets that have 1 element. Let's move on now for a set that has 2 elements. We will call it E. It might have yellow with red. Is it wrong if I write red then yellow? It's the same thing. Then F, yellow with blue. Then G, I might have red with blue. Do I have any other options? I don't have. And finally, I end it with the universal set because it's the only possibility to have the three elements together. Remember, we always write the sets as an uppercase. We give it an uppercase name and then equal and then the two curly brackets. And if we have elements, we put commas between them. So here I have listed all the subsets of the universal set U. All the possibilities, they are listed. Always start with an empty set and then start with a set with one element, list all the possibilities, then two elements, list all the possibilities, and then you move on until you end up with the universal set. And then you stop. You do not have any other options for. They gave us here a universal set, yellow, red, blue, and they're asking us a question. Is set A that has the element yellow a subset of U? How do we know if it's a subset or not? We look into the elements of the given set. Does the element yellow belong to the universal set? Yes, it does. So this set here, which is A, is part of the universal set. This is part of the universal set. But how do we write it mathematically correct? We say A is a subset of U. But we don't write subset, the word subset. We replace it by a symbol. This is the symbol of subset. And it is only used when we have a set in another set. We are working still in the same universal set and we have a question. Tell whether each statement is true or false. Let's start. It says that the set, why is it a set? Because we can see the two curly brackets that contain the element red is a subset of the universal set U. Let's see. First of all, before we say it's true or false, we have to make sure that we have the following conditions. First of all, to use the symbol subset, I should have two sets, and that's correct. This is a set because it has curly brackets, and this is a set, a universal set. So condition 1 is acceptable. Then I check, are the elements in this set inside the universal set? Red, is it found in the universal set? Yes. So this statement is true. The second statement, blue is a subset of U. True or false? We said we have two conditions. To use the symbol subset, I should have two sets. This should be a set and this should be a set. But look over here. This is not a set. Why it is not a set? Because I do not see the curly brackets surrounding the element. So directly without going to condition number 2, I write false. Why false? Because blue is not a set. So we cannot use the symbol subset. Before we take another example, I want to remind you with two symbols. A symbol that we took in the previous session, and it was belong. Belong, we used it when we had an element with a set. Today, we took the symbol subset. Subset is used when we have a set with a set. When to use belong and when to use subset is very important and must be kept in mind, especially with the true or false questions. So this is very important. Tell whether each statement is true or false. Let's start. 2 belongs to a set 1, 2 that has two elements 1, 2. First of all, we check. We are using here the symbol belong. And belong, to use it, we should have an element with a set. And that's true. This is an element because I don't have any curly brackets around it, and this is a set. So condition 1 is correct. I'm using the correct symbol. But step number 2, I need to make sure. Is 2 part of the set? Yes, it is part of this set. So this statement is true. Moving to the second statement. It says, set that has element 1. It's a set because I have curly brackets. Subsets. I'm using the symbol subset. The set that has two elements, 1 and 2. I have two conditions. I'm using the symbol subset. The symbol subset is used when I have two sets together. This is a set and this is a set. So condition 1 is acceptable. Now I look for condition 2. Condition 2 says that the element here must be part of this element. Is element 1 in the other set? Yes, correct. So this is a true statement. Statement 3. Set that has element 3 belongs to a set that has 1, 2, 3 as elements. Condition 1 is checking if I'm using the correct symbol. I'm using the symbol belong. And as we discussed, belong, I should have an element with a set. But here I have a set because I can see the two curly brackets. So this symbol here, belong, cannot be used with two sets. So this statement here is false. I should use, instead of belong, I should replace it with the symbol subset. Another example here, it says that we have element 4. Why is it an element? It doesn't have any curly brackets around it. Subset, the set that has the elements 2, 3, and 4. Is this statement true or false? Step number 1, we check the symbol that is used. We're using subset. Based on what we agreed, subset is used when we have a set with a set. Over here, this is an element and not a set, so I cannot use the symbol subset with it. So this is wrong, a false statement, because this symbol here cannot be used. I should replace it with belong. I have two sets here, set A and set B. There is a statement that I need to prove if it's true or false. It says A equals B. When do we use the sign equal between two sets? Set A equals set B. We use equal for two sets when they have the same elements, even if they are in a different order, because order is not important in a set, but as long as they have the same elements. Let's see. Set A has 4, 3, 2. So element 2 is found in A and it's found in B. Element 3 is found in A and it's found in B. Element 4 is found in A and found in B. Both they have 3 elements. This means that they are equal. So this statement is 100% true because the elements in A are the same as the elements in B. We are given 3 sets and we have 4 statements to identify whether they are true or false. We start with the first statement. It says 4 belongs to set that has elements 1, 2, and 3. Condition number 1 is make sure you're using the correct symbol. I'm using the symbol belong, and we know belong, it has to be between an element and a set. That's true. I have an element and I have a set, so condition 1 is correct. We look condition 2. Is the element 4 found in the set? No, I can't find 4 in the set, so this statement is wrong. 4 does not belong to 1, 2, 3. It's not part of the set that has the elements 1 and 2 and 3. Statement number 2. Set A is equal to set B. Remember when we said when we are using the symbol equal between two sets, this means that the elements in A should be exactly the same elements as B. Let's write them down. I have 4, 6 for A, and I have 6 for B. A has 2 elements and B has 2 elements. 4 is found in A and found in B. 6 is found in A and found in B. So definitely those two sets are equal. So this statement is true. Statement 3. Set B is equal to set C. I'm using the symbol equal. Let's list the elements and check if they are the same. B has elements 6, 4, and C has the elements 1, 2, 3. Before even checking, if you look over here, this has 2 elements and this has 3 elements, so definitely they are not equal. And this has elements 6 and 4, which are not found in set C. So this statement is wrong, false. They are not equal because they do not have the same elements. Statement 4, let's look over here. It says set that has the element 6 belongs to a set that has the elements 6 and 4. First of all, make a circle around the symbol that you are using. I'm using here the symbol belong. Belong is used between an element and a set. But here I have a set with a set. So this statement is 100% false. I cannot use the symbol belong. And because 6 here is found in the other one, I should replace the symbol by subset. Last example to recall how to write subsets. We are given a universal set U that has 2 elements 6 and 4. They need us to list all the possible subsets. As we said, we start first of all with subset A that is an empty set, has no elements, given the symbol phi. Then B, we start with now sets that have 1 element. 6. C, again, we have another possibility that might have only the element 4. Now we move on to 2 elements. 2 elements, this means the universal set because the universal set only has 2 elements and we're done. We cannot form a subset of 3 elements because the maximum number of elements which is decided by the universal set is 2 elements. So those are the possible subsets of the universal set.